Thanks for reminding. So we started recording now. We should be fine now. We should be good now. Regarding, sorry, I just stopped because we didn't. Some of the time is in just mute, right? So I just stopped. Thanks for reminder. If please do this reminder if I missed to fail to start recording, friends. Thanks. Thank you now. So it's good now. So this is all about bytes, friends. What is this bytes here? It is a simple collection of elements which is immutable. And then to create bytes, we use this bytes method. I'm just quickly recapping for recording purpose. And then here we cannot directly pass elements here to bytes. So we should take a collection and then that collection we should pass to bytes method. So we have took a list of elements here, and then that list we are passing to bytes, and then we are checking the type of that B. And usually this is a linear data structure. Bytes is a linear data structure. It has indexing both in positive and negative directions. You know, right? We had already discussed the same thing for string as well. So these linear data structures has indexing internally. So this helps us to extract elements without any difficulty. So here the index starts from 0 to size -1 and minus n to -1. And you can extract by choosing either positive index or negative index or by you applying slicing as well. So the syntax to extract elements is that variable name of index. And these are the examples that variable of 0 or 1 or 3, 2 or 3 or whatever the indexes that is there. Based on that index, you can extract elements. And if you want, you can also choose negative indexes to extract elements. It's up to you. And this is a slicing approach to extract elements. If you want, you can apply iterator and you can extract elements from these kind of collections. So this is a quick idea. What we do is let's go and test all this. Okay. Right now, sorry. Where is this? PyCharm. Yes. Just create a list of elements like this and pass that to the bytes function like this and then print it and then you can also test. You can also see for type here. Now, when we print this, you can see here B, internally, the values are stored as hexadecimal elements. Usually, in most of these programming languages, these integers are stored as one is as integers itself, decimal type. Okay, that is one thing. Second thing, these integers are stored as in our octal format or in hexadecimal format or in binary format, all different four formats. So what is this hexadecimal means? It has a base as 16 and it has a suffix as this x, small x or capital X. That represents hexa, which has a base as 16 digits. I hope this is clear. So what is the base we have? Hexa has 16 digits as a base. So that is the quick idea. Understood, friends? Now, you can see here the type of this collection is bytes in memory. Okay, so now this is a quick test. Now, what is that? Extracting elements. How to extract elements? Let us see that. So here, extract elements. For this, you should apply indexing. Simply speaking, print of, sorry, print of b of 0. Okay, similarly, you can print, like this. You have 5 elements, right? Okay, b of 0, b of 1, and then b of 2, something like this. This is one way of extracting elements in each independent element from the collection. We have indexing till 4. It starts with 0, ends with n-1. This is one approach. You can also extract elements through negative indexing if you wish to. Okay, it's up to you. So maybe this is a extracting elements through negative -5, -4, -3, -2, -1. Similarly, you can apply a slicing as well. So what is that? Print of mm, P of 1:3. It gets just two elements. Okay. So this is applying slicing. This is one more approach. So you can see here. Now run this. Run this. You can see two sets of outputs. One is through positive index. The second one is through negative index. You can see here. We have already observed that index here. So you can see here there is a positive and negative index here, right? Through this, we can extract our elements, right? So let's see, right, test this, run this, and you can see elements here, friends. So same output we got it. Suppose if you want in reverse order, just change this extracting elements so that you can get it in the reverse way as well. And then this one, and at the end, print, sorry, I put P. P doesn't have any sense. Okay, let me put P here. Okay, why I am not getting output for slices? I put P, which is not there. It's actually an error. Okay, so right click and then run test. Now you can see we got the output for 1 and 3. Right? If you try to apply slice again, still it is shown as a hexadecimal. But if you extract each element like this by applying index, we don't see the output in hexa form, but it is shown in the form of integers here. Okay. So that's the simple idea, friends. Next one. Suppose if you ask me, can we apply this iterators, all this stuff on this Manoram? Then the answer is yes. Suppose use for loop for I in B. This for loop is specially designed for applying on this specially designed to apply on this collections. So you can pass this like this for dummy variable in collection, and then collection means it can be B. Now it is bytes, right? So you are passing B. Similarly, you can pass list, you can pass set, you can pass anything, any collection in the place of this variable B here. This is the place of collection. You can pass anything here. And this is the dummy variable where this variable is a local or temporary variable here, right? Now print off I. Now we are extracting elements, printing elements through what? Applying a loop. So printing elements using a for loop. Okay. Now run this. Now you can see this output is from for loop here. Maybe if you want, you can add a print statement as well. Okay. So this is a quick idea, friends. This is a quick idea how to create a simple collection, and then how to, in most of the cases, to create a collection, you have a method like this, friends. What is that here? You have a method given for to create bytes, you have bytes. You have to create array byte, you have array byte method. Likewise, to create a list, there will be a list method. To create a tuple, there will be a tuple method. To create a set, there will be a set method. Like that, to create each type of collection, we have one method given, friends. So using that method, we can easily create any collection that we need. Okay. So this is a quick idea. I hope the steps are clear, right? So we'll talk about list later. This is not immediately needed. So, okay. So within the next few minutes, we talk about list as well. But this is a quick idea about this bytes thing. Let's test a few more points about bytes. Let's see. Let's also test few things. We told this is immutable, right? This bytes is immutable. Let's quickly test on this immutability of bytes. So it means we cannot modify this. Suppose let us change this elements of byte and see, friends. So what happens here? Okay, let's see that. Sorry. Uh, so this is clear, right? Can you please confirm? Are these concepts clear so far? What we discussed with bytes? All things related to bytes. How to create bytes? How to, okay, print elements from bytes? how to apply looping, how to apply slicing. All these things are clear to you, friends. Can I get an S from all of you? Can you please share me your feedback in the comments? Others are fine, right? With this? Okay, no problem. Then there are few things you need to cross check on this bytes thing. So what is that? One thing to check immutability. Let's see here, friends. So suppose what is immutability, friends? What is the meaning of immutability? Can you answer in the chat box? Simple answer. I don't need lengthy answer. We cannot modify an object. That is immutability. Let's test it now. So you can remove this now, not needed. Okay, because we are testing few features. Already we test this. So I'm removing this print statements, all this. Anyhow, this will be there. This recording will be seen in the okay. All this will be in the recording. If you want, you can go through it once, friends. Now, this is X, right? Let's do one thing, not X, B. I'm trying to modify this B of some first index equal to some 100. And then I'm printing a P of 1. Usually we can do that. I'll show you in a list actually. Now run this. So what we are doing here, we are changing the element of B at first index. So earlier element of B at first index is 2, but now we are modifying it to 100. So and printing this, let's see what happens here. Let's run this now. Run. So what is it saying? What is it saying here? It's a type error. We tried to modify the element in the bytes collection. We have assigned this first index with element in first index with 100. But what's that error we are seeing? Type error. And what it is saying, friends? Bytes object does not support item assignment. Sorry. It doesn't support item assignment, friends. Means what? You cannot modify this bytes collection at all. So that itself is a clear proof that bytes is immutable here. So at memory level, you cannot modify. At program level, we cannot modify bytes collection. So that's why assignment is not possible for bytes collection. It is strictly immutable, right? So that is a quick check we did for bytes here, friends. Okay. So that's all, friends. So to prove that point, so what is this? Bytes is immutable. We try to reassign value, but it's not possible because that is not supported for bytes collection. So this is all about bytes collection, friends. So I hope all of you are clear with this, right? All of you are good with this, right? So we'll be more doing similar scenario again with another concept, right? If you want, you can try these examples, okay? So program to find sum of all elements from bytes. These are all few use cases I have built on top of bytes. Maybe if you want, you can try that, no issues, okay? Earlier we tried it. And this is the scenario which we tested just now. These collections, these programs, all that we'll do one session as a logic implementing session, okay? So next one, here if you see, we are checking the scenario. What is that scenario? We cannot modify bytes because bytes are immutable. I think this should be clear. We already tested this use case. Sorry, where is this? I'm coming to this number. We tested that use case. We tried to modify bytes collection. But is this possible for us? It's not possible. Okay. So that's why we tested that and we found that it's not possible. Then we just skip now. The conclusion is clear for us. Okay. That's it, friends. And also one more important point here. What should be the range of elements of bytes here? So this is another important. This byte collection, bytes means just what it allows elements only up to 256. It allows only elements up to 256. You see here another important point. Of course, this is we don't use this collection much, but still what we are doing, friends, we are trying to check all the pros and cons of bytes collection. So another important point is you see in this collection or in this list, we took elements within a range from 1 to 1000. You have elements 1, 10, 100 and 1000. Now let's print this X. Let's observe it programmatically. After printing, let us see what happens. Right click. Sorry, did I create any bytes collection so far? Do we have any bytes collection here, friends? I am trying to involve you. You friends, please answer yes or no. Do you have a bytes collection here, friends? Please answer in the chat box. Please comment in the chat box. Do you have that? Correct. So to create that, what should I do now? Which method should I apply here? Because the process, once you understand this one collection, the process is same for all collections. It's not just for bytes, friends. If you spent a little bit time here for this bytes, it is almost similar for array byte or list or tuple or anything. Got it right? Concept is same, but we learn more concepts on top of each collection. So now, how to create bytes collection here? How to create bytes collection? So yes, your answer should be fine. Somebody is giving me answer. So I should use a bytes method here. So some y equal to bytes of x. Okay, this is fine. Now what is that we are testing here? We are trying to print y. So what is our test here? We are testing the range of elements bytes accepts. Byte accepts elements from 0 to 256, means up to 255. Now we gave 1000. Does this 1000 is accepted by bytes is the question. Okay, like run this now. Now you can see here, byte accepts elements within a range 0 to 256. So other than, see, if you exceed anything above 256, then it is not accepted in bytes. We got this, friends. This is not accepted in bytes here. Okay, I hope this is clear for all of you, friends. So what is this allowed range of elements within this bytes collection here? 0 to 256. Other than that, it won't accept. Let me check if it at least accepts 256. I doubt if it accepts 256. Let me test it. Even 256 is not allowed. Then does it accept 255? At least till 255? What's your answer? Before I run this program, please let me know. Is 256 allowed in a bytes collection? Please answer in the, please comment in the chat box. Is 255 allowed in bytes collection? What's your answer? Yeah, thanks. 256 should might, but please keep answering, friends. No problem. Yes, this is allowed. Right click, test it now. You can see, right? You can see this that 255 is allowed, and these are what shall we say, hexadecimal notations. Don't bother about that, right? That's a simple thing, friends. Even 256 is not allowed. Just remember. Maybe these scenarios are useful for some interviews or some kind of written tests or some certifications. Okay, friends, that's all. Okay, that's a quick idea. So I believe this is all about bytes collection. Okay, we have covered almost all everything, and also one more important scenario. This bytes collection, this accepts only elements as objects, cannot be interpreted as integer. It accepts only integers. See, in this byte collection, I tried to pass this decimal elements, but this is not accepting. See here, friends, let us test it quickly. I put a decimal element here. Let me put a decimal element. Okay, let's run this now. What happens? Let us see. What happened? Float object cannot be interpreted as integers. Means what? This bytes collection accepts only integers as input. It won't accept any other type of elements. What is this bytes collection does here, friends? It accepts only integers, but not any other type. And if I try to pass decimal to this bytes collection, what's happening here? We are seeing an error. So remove this. So remove this. So this is another important point. Bytes collection doesn't accept any other value except what is that, friends? Integers. Suppose I try to pass some string here. Let us see if it accepts a string. So test it. You got an error again. So from this we can conclude that a bytes collection accepts only integers. It doesn't accept any elements other than integers. That is point one. Point two, it is immutable. If you try to modify or reassign elements in a bytes collection, it is not possible. You get an error again. So that is another point. Point three, the range of bytes collection is from 0 to 259. 256 means still 255 it is allowed. 256, even 256 is not allowed. You can remove this now. And then to create bytes method, use a method function called bytes itself. For that, we should pass and explicitly we should pass an existing collection like list or some set or tuple or anything to bytes collection. So these are important points associated with the bytes collection, friends. Is this clear for all of you? So that is what we had discussed here about bytes collection. Understood, right? Let's switch to byte array. What is byte array? Byte array means bytes and byte arrays is same, but byte array is a mutable object. What is mutable and what is immutable, friends? What is the difference? Both are same. Bytes and byte array are almost same, but the difference is bytes is immutable, byte array is mutable. So can you please answer in the chat box? What is difference between mutable object and immutable object? Please answer in the chat box. Come on, friends. So mutable means
Hello. If you are speaking, you are on mute.
thanks for that. Yeah, just I just muted. So yeah, thanks for reminder. Uh, yes, I am in mute. Now it's audible, right?
Yes, yes.
Yeah, just muted due to some noise there, but it's okay. Now it's clear, right? So we are talking about byte array. So for byte array, see, we already know it is an immutable, it's a mutable object. Mutable means we can modify these objects. And also one more important point here is it also falls under the same range, friends. What is that? The range is exactly same as the bytes collection. It's up to 0 to 256 only. Means it accepts up to 255. That's all. And to create this byte array, we use this method byte array itself. And before that, what we should do? We should create a list of elements like this. List means what? Simply use these brackets and then internally pass elements separated with comma. And this is simply called as a list here, friends. Okay. And then assign it to some reference like X or Y or whatever you want. And that you pass to this byte array method, then this object is created. To test it internally, what is this object? So you can apply type function here. So we are testing the same here. We created a list of elements within the range of that byte array. And then here, instead of byte, we should choose byte array. You can see in the this thing also when we say this, it is automatically showing us in the support. Okay. So now I choose byte array and then I am passing this list to this method and we constructed this byte array. Now we are printing this byte array. And if you want, you can also check for a type of Y. Okay. And then what? Right click and then run test demo. So there is a name error. What is the name error? Let me quickly see here. Y is, yeah, sorry. Here, if you see, it is uppercase Y. So that's why it's showing error. Yeah, that should be fine. So you can see here, right? Now that issue is fixed here. Right click and then run test. You can see now. So this is byte array. Even in this case of byte array, the elements are represented in hexadecimal form. You can see here. There is a prefix of /x, which represents these elements internally are stored in the form of hexadecimal, friends. And then when you check the type of this one Y, internally it is showing as a byte array. It is an object of byte array type here, friends. You can see here. This is a quick idea. But what are important points about byte array? Simple, right? What is that? One is it is mutable, right? Mutable means we can modify it, right? So let us test mutability of byte array because bytes is immutable and we cannot modify bytes. But this bytes array is mutable, so we can modify this. Let's apply this. So x of some 0, right? This has indexing similar to bytes. Even same, this has indexing. So this is 0, this is 1, this is 2, this is 3, this is 4, right? There will be an internal indexing for this. So let's do a byte initially, this assignment. Let's reassign a value of this byte array. The 0th element is assigned with some 100. And let's print that byte array again, or maybe yes, you can print byte array, or you can iterate it and see, because these are hexa form, right? No problem. Let us print and see what is if the change is allowed. That is first thing. Second thing, once if change is allowed, so how this element look inside this byte array? That is the second thing we should observe. So right click and then run this one. And when we print this byte array after changing element, so internally, now we are not able to see that difference because the output seems to be same for us. So for this, what should we do? Either try to print element from 0th index explicitly, or otherwise apply an iterator on this so that you can clearly see that modified element inside this byte array. Another important point is here when we once we modify this, right? Once we modify this element, what you can do, if you want to see element, like you can do something different. Print of x of 0. When we do this, you can clearly understand what element is present in 0th index after making change. And another important point is when we do this change item assignment, when we reassign this value, this time we don't see any error, and this operation is allowed. We are allowed to modify this byte array. So means what? That is the mutability. Mutability means we can modify certain elements in this byte array. But for bytes, it is not allowed, right? Not certain. We can modify byte array. Certain means only few elements, some type of elements, but this byte array can be modified. So when we modify this, assign this 100, reassign 100 with it to 08 location, this is allowed on byte array. So that itself, it proves that this byte array is mutable. I hope this is clear for all of you. So this is mutable, friends. Is that clear? Now we are trying to print that what is in the 0th index. Earlier in the 0th index, it is 0. Sorry, it is 1. But after changing, it should be 100. So what we do, let us print this x of 0. Sorry, not here. Before changing, what is there in x of 0? After changing, what is there in x of 0? After modifying, right click, test this. Now you can see before we modify that x of 0, the 0th index, the element in that 0th index is 1, friends. After modifying, it is a 100. You can see that difference here. Okay, right. Clear now? So from this, what is the conclusion? What is the conclusion, friends? Byte array is mutable. Can we modify byte array now? Is it possible, friends? Is it possible to change byte array? Please answer in the chat box, friends. Possible, right? Please mute the. Yeah, thank you. So, yes, next one. If you want, the concept of byte array is exactly same as a bytes collection. No big difference, friends. It's almost same. So you can apply it has indexing again, positive and negative indexing. Okay. So now if you want to print elements, you can say something like y of 0 and then y of 1, something like that. So y of 1, y of 2, y of 3, y of 4, something like this. Okay. So because it has internally an indexing for these kind of collections. You can also choose negative indexes. This is one approach, printing through index. So what we are doing, printing element using index. Using index. You can choose negative index or you can apply slice operator as well on these kind of collections. Okay. Maybe you can see more on this on list collection. We do few use cases. We apply few use cases on list, so you get more detailed picture about all this again in list collection. So all again list is a kind of revision for bytes and byte array. Okay. Next one. So this is one approach. We can use index and try to extract each element from the byte array. That is one scenario, friends. Suppose instead of extracting each element from byte array, if you want to apply an iterator, then what you can do? You can use while loop or for loop. But which is most recommended loop when while dealing with collections more than while? For is the best loop recommended. So what do we do right now, friends? So let's apply for loop. Printing printing using loop. Now what do we do? For some dummy variable in this collection byte array. Okay. And then print this I. That's all, friends. You can see now. So this is printing through loop here. So the first scenario is printing through indexes. So let's run this now. So there is a some index out of range. Where is that index out of range? 0, 1, 2, 3, 4, 5. Yeah, here, this one. You know, what is this error? You need to keep a tab on all these things, friends. So why this is index out of range? Because we have how many elements in this collection? 4 elements, and the index will be up to 3. But I am trying to extract an element from 4th index. So this is not allowed. Remove this. Okay. So now right click and then run test. You can see now. So this time we are good here. So we are printing element using index, and you can see all that 4 elements are printed here. And similarly, the same thing we are doing using loop, and all that 4 elements are printed here. Right? This is a quick idea about byte array. So what is that we do here? So here we are creating a byte array and then checking the mutability and then printing elements through index and then printing elements through iterator, that is for loop. Okay, that's all about byte array, friends. I hope you are good with this. Maybe if you want, you can try to do some logics. You can apply some logics and byte array or bytes if you want. But maybe we will do that in with list collection. Anyhow, if you are familiar with one collection, it is almost same for any collection. So we do some use cases on list collection. But till this, are you good here? Before I switch to the this one, friends, which one list concept, right? So let me ask you quick questions on bytes and byte array, friends. So I hope you are ready for that, right? So first thing, shall I ask quick questions? Are you ready? Let's see this now. What is quick difference between bytes and byte array? So what is difference between, what is one major difference between bytes versus byte array? You know answer now. So what is the answer? Please comment in the chat box, friends. One major difference between bytes and byte array is okay. So one is immutable, the other one is mutable. Thanks, friends. Other things. So another question. What is the range of element allowed in both? What is range of both? Range of elements, ELE elements of both collections. Does it allows any range of values from minus infinity to plus infinity? Is that possible with these two? Please answer this quick question, friends. For both, anyhow, the answer is visible on top of you only. It allows within a range 0 to 256, friends. That's all right. 0 to 256. Even 256 is not inclusive. This is exclusive, friends. This is not allowed. We tested this. Means it accepts up to 255. Right? I hope this is clear for you. Right. These are quick differences. Let us jump to another major topic in Python. Very crucial topic, important topic in Python, that is list collection. So here I spend a little time here. I spend more time on list concept because in a real scenario, in a real development, in majority of the cases, we are going to see a list collection here. Okay. we are going to use much of a list collection, friends. So let us stay here for a while. So what is list now? Let us start it. What is a list? Again, this is also similar to bytes or array byte. It is not something different from bytes or array byte. This is similar to bytes or array byte. But both bytes and array bytes are little, they store elements in the form of hexa format. But here, list is not like that. It is a general purpose data structure. So these here, the elements are stored as integers itself. The elements are stored as is. However you pass in the same format, the elements are stored here. So what is list here? Same thing. It is a mutable order of elements. List is mutable data structure, uh, and it stores elements in the as per the index, and order is preserved here. Means as per index means in whichever the order you pass elements, in the same order elements are stored here, friends. Okay, we will see that with example. Maybe we'll check and prove with an example. That should be fine for us. But what is list here? List is a immutable collection where order of elements is preserved here, friends. Is that clear? So that is important point. Next one. Just like any, so list is like just like an array in other languages. So if you are familiar with array, maybe in C language, C++ or Java or C sharp or any other languages. So what is list here, friends? It is similar to array in other languages. Array means group of elements, which is where it follows a sequential order, arranged in a sequential manner. Means the index is created like 0, 1, 2, 3, 4, 5, something like that. And that is what we call array. And similar kind of array concept is applied in on list in Python. But difference is in C++, you don't have the kind of flexibility what we have in Python. Python is most flexible compared to C, CPP, Java or C sharp. Okay, list is much more easier in Python. Is that clear, friends? This is a quick idea. So summarizing this point, it is something like arrays in other languages. Okay, next one. And here, if you read an element from a list, what is that we do is the point is a list uses indexing to extract elements from this data structure. So this for sentence formation is not 100% valid. If you read an element from a list using, so we should say using a concept of indexes means what? List internally uses indexing to extract elements from the list here. Okay, so that is another scenario. Clear, friends? So it uses indexing internally. Next one, and the index starts from 0 to size n minus 1 or minus n to minus 1. So how the indexing starts here? Indexing starts from 0 to size minus 1 or n minus 1. This is fine. Or minus n to minus 1. This is another important point to remember. Right? Next one. And here list supports homogeneous and heterogeneous data. Maybe I don't want to confuse you. It supports heterogeneous data. So when it is heterogeneous, you can have all homogeneous inside that, no problem. A similar type of data or different types of data, but still list supports different types of data here, friends. Is that clear for all of you? So that is another important point, right? So, and then list is dynamic. Dynamic means you can add thousands, lakhs and crores of objects in list. Is that clear, friends? This is another important point. So summarizing the all important points of list, what is that, friends? The first one is list is mutable. That is first one. Second thing, it's like an array. It's more of a linear. It's a linear data structure. which has indexing internally, and the indexing is 0 to, usually it will be positive or negative indexing. So it's 0 to size -1 or -n to -1. So it has both the both directions, a positive and negative direction indexing, and it supports heterogeneous data. Heterogeneous means different kinds of data, storing different types of data. It allows int type, float type, double type, string type, character type, or any different types of data. If you want, you can store tuples in list. You can store any other collections inside list. Okay, so in that way, a list is heterogeneous in nature, means it accepts different type of data. So that is a quick idea, friends. And this is dynamic. Dynamic means what? It is automatically increment. It is incremented automatically and decremented automatically. If you add increment, if you add elements, the size is increased. If you remove elements, the size is decreased. And this is done automatically. And this nature of any collection is called as dynamic. Means if you add elements, the size increases. If you remove elements, the size decreases. This is called dynamic nature of a collection. Clear? So that is a quick idea. So these are the important points to remember, are an introduction to list collection. Okay. Then the next thing is you might be very curious. What is that curious question? How to construct a list? How to create list? Right. We can create list in multiple ways. So what is that? Let me just show you, just a minute, friends. Sorry. So what are different ways of creating this list collection? So you can see we can create list in multiple ways. One is by using this list method. I'm going very slowly so that you can easily understand. So what is this list method? You can see it construct a list from any iterable object. See, again, this is important point you should observe. Not from any object, any iterable object. Iterable means what? It should have group of values inside that. This for loop is applied only on collections. Iterable means something which can be iterated, which can be looped. That is called iterable object. Following, friends. So one thing, using list method, you can create a list. That is fine. So what this list method will do, it construct a list from any iterable object. That is also fine. What are these iterable objects? You can see here. These are all iterable objects. What is this? List, dict, set, tuple, string. All these are bytes, array byte. All these are iterable objects. And from these iterable objects, you can construct this list object. Also, this point, I thought to show you this point. What is that? So this one is there, right? This bytes are byte array, all this. If you want to, let me show this important point so that you get some idea. So you take bytes example, suppose x equal to bytes of some 10. I am not creating a list. I am not creating a list collection first, a list object first. What I am doing, I took bytes collection and then directly passing a value without constructing a pre collection like list. Okay, so now let's try to print it and run this. What happens? See this now, friends. You get a clear picture. What is iterable, right? So let's print it. When I print x, what's happening here? It's giving. You can see we don't even understand the output. Let's print it. Print of x of 0. Let's see this now. X of 0. Run this now. Okay, not like that. Run this one. And what is the output you are seeing here, friends? See here. When we print x of 0, what is that we are seeing here? We are seeing 0. But we are not seeing 10. Why? Because it is just taking this and trying to convert into some format, but and it is not accepting as a 10 itself in memory, right? It is stored in some other format. Why? Because to this collection, you should pass elements as what, friends? You should pass elements as iterable object. But is 10 an iterable object? It is not iterable. It is not. There are two types of values in programming: vector values and scalar values. This is a scalar. Scalar means just a simple type, unique type. Vector means iterable. This is a scalar element. When you pass a scalar, so internally it's stored in some format. When we try to print an element from 0th index, assuming that one value is there, we are not seeing that 10, but it is giving us some unknown value which we pass. That is 0. We didn't pass 0 here, but we are expecting 10. That is not possible. Why? These collections internally accepts iterable objects. Suppose you see 0, 10, comma 20, comma 30. You didn't ask this question to me. You can ask me, Manoram, why didn't you pass like 10, 20, 30 directly? Why you are initializing to a list and then why you are passing it to the bytes collection? Right? You didn't ask this question, friends. But anyhow, situation came and we are discussing it. So yeah, I tried to pass multiple elements directly to bytes array like this without creating a prior list or something, without building a collection first and then passing it. So if I do like this, let's see what happens. Let's run this now. Run it. You got an error. What it is saying, bytes argument. So you can see here type error. What it is saying, argument 2 must be string, not int. It is asking something else here. Means what? So if you directly pass multiple elements to a byte, actually still it accepts elements from 0 to 255. But still, if I pass 3 elements directly, it is not allowing us to accept these scalar values. These are not vectors. Vectors means something like a collection, group of elements. But I try to pass scalar elements, it's not allowing me, right? So let us see one quick change here. This is only to cover up this point, friends. Iterable object. What is an iterable object? I am trying to give a clear picture. Like what if we directly pass the scalar elements? Scalar means which are unique elements like 10, 20 independent elements, not group of values, right? So when I pass this, this is not allowed and it is showing an error. But suppose you see, I am passing elements in a list now to a bytes. Is this a quick question for you, friends? Is this a scalar object or a vector object? Vector means group of elements, friends. Is it a scalar or a vector? List one. Is list a scalar or a vector, friends? Or is it iterable object or is it just an independent element? Please answer in the chat box, friends. Understanding this concept is very important. So I am trying to give a clear picture as much as possible on this. Now, I changed this to a list. Is it a iterable object or non-iterable? Is it a scalar or is it a vector? Please give me answer in the chat box, friends. Please answer in the chat box, friends. So if your involvement gives me more energy. How about others? Others, friends? Okay. So this is now I think it should be fine because we are passing iterable element. So right click and then you can see this time we are seeing elements in a right order. In a right, we are seeing right values, right? Proper values. Why? Because we are passing all these elements as an iterable object in an iterable object, and then we try to print that, and then we are seeing a proper value here in the output. So this is a simple idea. What is that simple idea? What is it? This list allows values in what format, friends? This accepts elements in iterable object. I hope this is now what is iterable object? Something which is having group of values in it. Okay, let's switch to the next topic here. So here for these kind of collections, If you want to create them, then we should create them through iterable objects, not like by passing direct values like scalar values. Okay, now let's create a list now. How to create list? If you want to create an empty list, we can create it like this, friends. How to create it? Like this. You can take a list method and just assign to some variable like this. Then what happens? This creates an empty list, friends. Then after that, what we can do? We can add elements to this empty list. Okay, let's test it now. We can create list in multiple ways, and we can add elements to list in multiple ways. We'll do one by one. Okay. So now let us just quickly test this example. Let's apply a list scenario. Let's keep bytes as is. We don't need to change this byte scenario. Okay. I'm just keeping that. Okay. I'm just adding it as is. Let's be there. Okay. Let's take one more file here, and then let us take it as a Python file, and then we can say list demo here, and then let's test it now. So what this first line does, it creates an empty list, and then we are printing that. Okay, and let's see what is the output we get here. Right click and then run it. Here, this is actually not a Python comment. I used Java or CPP comment. So this should work now. Print it now. So what did we do? We created an empty list. So this is a simple, quick idea. If you want to create an empty list, just create a list method and then assign it to some variable or reference like this. And then you can print it like this. So we can see the empty list here. And later on, if you want, you can keep adding elements one by one by using a method called append method. We'll see that one by one. I hope this is clear for all of you, how to create an empty list here in Python. So next one, another scenario. So scenario one is creating empty list with list method. Without list method, you can create a list. What is it, friends? We can create a list. Yeah, it is heterogeneous, right, Suresh? List is heterogeneous. Heterogeneous means it accepts different types of values. So it's not just accepts only integer. It accepts a decimal. It accepts string. It accepts a complex. It accepts boolean. It accepts another kind of collections like list allows tuples, list allows set, list allows dictionary. Hope this answer your question, Suresh. So what is the conclusion? It is heterogeneous in nature. Heterogeneous means it accepts different types of values. It's not just only integer type. Okay, that is the answer. Okay. So now second type of constructing a list. What is that second type here? Here instead of using list method, you can use this brackets, the square brackets to construct a list. This is a static way of creating a list here. So what is that? Use square brackets and pass elements inside that square bracket separated by comma here. So square brackets inside that val1, val2, val3. This is a simple way of creating or constructing a list. This is approach 2 and assign to some variable. Okay. So now when we create a list like this, see, you can, this is the example of a simple list. Now you created a list like this, for example, sum x equal to 1, 2, 3, 4, 5. Just take list of 5 elements. Okay. When you create a list of 5 elements here. Okay, friends. Now you can see here for that list there is an indexing. The indexing is in positive to 0 to n minus 1 or minus n to minus 1. Right. We have these two indexes for this list here internally in memory. Now, this is a quick observation. When we construct a list has indexing internally because all these are sequential data structures. When it is a sequential data structure or linear data structure, these kind of data structures have indexing internally in memory. So This indexing looks like this. I hope this should be clear for all of you. By now, you should be familiar with this indexing concept, right? So now, once you construct a list like this, and once you are very clear that there is an indexing internally created for this kind of linear data structures, and that index from 0 to n minus 1 and minus n to minus 1, then you should know how to extract these elements through using these indexes. So that is the next thing. Once you construct a list like this, suppose this is approach one, we are familiar. So I'm commenting this. Next, doing a following approach two of constructing a list. What is this x equal to? You can choose any variable or any reference of your choice. 1, 2, 3, 4, 5. Even elements, it's up to you. It's your choice. Okay. So now, so print of a x, do it directly, no problem. Now right click and print this. What happened? You are able to see the list as is without any internal change. You are not, these are not stored as a hexadecimal format or any other format if it is a list collection. And the elements are stored as is, right? That's what happens here. Some of our friends are asking questions like, if this is, let us quickly have test a few important points about list. So what is this? This list is dynamic. Dynamic means you can keep adding elements, you can keep removing elements. Suppose I add one more element to this list and one more and one more. You can do this to add crores of objects to this list. List accepts crores of objects, not just one or two. So it is dynamic. You can keep adding how many other elements you want to this list. I hope this is clear. How many other elements you want to add to this list, that many elements you can add to list. Now you print it. This is it is increasing size internally. Right click and print it. Now you can see the size, the elements is included. They are added to the list, and then you can see a change in the size of values here. I mean the size of list. Suppose remove few elements. Remove few. Now elements are removed. Now run this. Now you can see there is a decrement in the size of list. Means this is dynamic. Dynamic means when you add element, it accepts those. When you remove elements, it decreases the size. So this is dynamic nature. Dynamic means increasing or decreasing size of your data structure is dynamic. Okay. So list is that. That is one thing. Second thing. So point one. What is that point one? We tested dynamic nature of list. Right? Point two. Heterogeneous or homogeneous. Homogeneous means all elements of same type, friends. Like for example, so far we discussed, this is the third data structure we are discussing for today. We had discussed about bytes and byte array, and this is the third one. If it is bytes and byte array, right, you have observed very clearly, both accepts only what type of values? Both accepts bytes are byte array. Accepts only what, friends? Only answer. Please comment in the chat box. Either bytes or, okay, byte array. Accepts only what? Please answer in the chat box. They are homogeneous actually. In a way, they are homogeneous. Means they accepts only. I hope we have observed that topic. We had discussed that. Please answer in the chat box. What they accept? They accepts only. I'm waiting for your answer, friends. Exactly, integer. These accepts only integers. So if you try to pass any other value, you have observed it has thrown an error. That is called homogeneous nature. Accepts only a similar type of value. Accepts only similar type of value. That's called homogeneous.
Heterogeneous means what? Suppose the first one is integer, second one is decimal, third one is boolean, okay, and fourth one is a complex, okay, some 4 plus, okay, some 6j, like this. And fifth one is a, maybe you can take, did we cover everything? String. Maybe you can take some a string here. I just put a string. Now print it. And this is called heterogeneous nature. What is it? This is heterogeneous nature, allowing different types of values in a data structure or in a data type is heterogeneous nature. Now list is heterogeneous, but if you talk about, maybe if you ask me an example to show homogeneous nature of some collection, bytes and byte array is the best example because both accepts only integer type and they are homogeneous in nature. But if it is a list, it is heterogeneous in nature, means accepts different types of values here. I hope this should be clear for all of you. Next one. Third scenario, order is preserved. Order is a preserved. Sorry. What do you mean by order is preserved, friends? Means in whichever the order you are passing elements, in the same order it extract elements. Suppose you passed 1, 2.5 true and tuple and a string here non-tech. In the same order, the values are printed here. Suppose if it is set or dictionary, you cannot expect the elements are stored in the same, preserved in the same order. Right? Means they preserve elements according to hash code. Is that clear now? So here order is preserved because these are linear data structures and elements are stored according to indexing. So that is another important point. Insertion order is preserved here. Clear, friends? And if you want, you can add null values as well. Nulls are allowed. What is that? Nulls are allowed here. So what is that null? Something like this, comma. This is a null value. If you want, you can pass nulls. Let me just pass like this, not this. Yeah, you should say none. I'm sorry. Here the null can be passed as none. Okay. Now right click and then print it. You can see nulls are allowed here. So in some other data structures, nulls are not allowed, but here this is allowed here. I hope this is clear for all of you. So that is another important feature of list here. So what are those features? Dynamic, you should be clear, right? And second thing, homogeneous or heterogeneous, you should be clear. Third thing, insertion order is preserved, you should be clear. Fourth thing, nulls means here it is none. In Python, null we call it as a none. None is a built-in literal. So if you don't want to create, if it means none represents an empty object. Right? If nothing is there, then we call it as null. Okay, that's a simple idea. So now I hope you are clear with all the features what we discussed in the beginning here. If you see all these important points we discussed, you should be clear here, friends. Understood now? So this is a quick idea, right? And so we have proved each and every point, right? Everything that is related to list here. So anyhow, let's switch to the next point here. So we created a list now and we try to add multiple different elements and we printed. We are good. We don't see any issues here. This is working for us. Right, next one. So how to extract each element from through index? Another scenario. Extracting, printing elements through index. Printing. So he's simply speaking, printing elements from list using index. Okay, let's do that. So how do you print it? Something like print of x of 0. This is applying indexing, and this is the syntax. If you want to extract an element from a list, how do you extract it, friends? You extract it by applying that variable name in brackets, choose index. Choose index. Okay. So what do you do right now? So x of 0, x of 1. Make sure you don't go out of index. You have seen in today's session few examples where if you try to print an index that is not existing, it gives you an index error. So make sure while printing these kind of data structures, you are not reaching out of index. That is very important. So 1, 2, 3. Can I print two more? 1, 2, 3, 4, 5, 6. We can print up to 5. 3 and then 4 and then up to, if you want, you can print 5 also. It's up to you. It's not necessary to print all elements, just 2 or 3 prints is enough to test that, to understand that how to extract each element from this list using index, right? Right click and then print. Now you can see all the elements got printed in the output. You can see here. Maybe you can also use some negative indexes, something like -3 or something like this. Can I construct index in jumble? It's not possible, Suresh. You cannot control indexing. Indexing by default always creates from 0 to n-1 and -n to -5. This is not in our control, developer control. This is automatically created when we construct what? Construct a collection. Is that clear now? If straight answer to can I construct index in jumble? Straight answer is no. It's not possible. Why? Because we don't these are linear data structures, and always indexing will go in an incremental up order, and you cannot jumble these indexes. If you do that, then you cannot work with these data structures. It's not possible. I hope this is clear. Still you have any question? I see that you are typing something. Okay, let it be. Meanwhile, I'll discuss on this. So this is how you can print elements using index explicitly, friends. If you want to print each element from collection, and this is how you do here, friends. Okay, either you can choose positive index or negative index. It's up to you. Right. This is a quick idea. Next one. Let's run this now. What happens? What is the output you see here? You see some output here. This is fine. No problem. Okay. Right. Next one. This is approach 1 to print elements. But do you think this is recommended? This is recommended approach to extract each element through this index. Is this the recommended one in a real development? What's your answer, friends? What's your answer? Yes or no? This is not recommended one, friends. This is not recommended. So if it is a collection, iterating using that for loop or iterator is very important. Using loops is the most recommended one when you are working in a real development. Okay, next one. Printing. Print. What do? You are printing elements using what is that we do, friends? Using a while loop. Using for loop, sorry, not while loop. We apply for here. For is recommended one on collections. So what do you do right now? For some dummy variable in collection. What is that collection here? Our collection is X. Put that here and then print I. Okay. And then print this. You can see here now. So this is elements we are printing using loop here. This is the output we are printing through index. So this should be clear for all of you, right, friends? So this is case 2. What is case 1? How to extract specific element through index. We did that. And case 2, how to extract elements through loop. That is case 2, approach 2. And in tomorrow's session, tomorrow in sense next week, we try to cover more scenarios on this list concept. I hope this is clear. We'll cover up more scenarios on list concept, friends. So I hope you had a good this thing on this collections today. So you are able to get a clear picture about how collections look like byte or byte array or list. And also we understood about multiple things, mutability, immutability, and also range. For list, it is unlimited range. There is no confined range for list because list is a dynamic data structure, unlike bytes and byte array. Okay, friends. So, so in the next session, what we do, we cover up more scenarios on list, and we try to implement few use cases, few examples as well, and we'll get a deeper understanding about list data structure because this is very important for us. Okay. Any more questions? You can stay back. Else, have a good Sunday. Thank you, friends. And thanks for reminding to record this. Please keep reminding if I forget to miss to record. Thanks to everyone. If you have questions, you can stay back. Else, we connect next week.
Hello.
Yeah, Harish, please.
Yeah. So next class we can discuss like minimum maximum of these things, right?
Yeah, we'll do some scenarios.
Yeah,
Okay. Maybe if you want that example, I'll show you next week. Okay.
Yeah, sure.
No issues with that. Okay.
Thanks for
Okay, friends. Thank you. I see. If you have any questions, you can stay back. Else, I'll share the recording. You can go through that. Thank you.